Thank you very much. Okay, so how to and why should we run our own Ethereum nodes? This will be a cooking show with me and Paul. Mostly me, it sounds like. But Paul will show off his DappNode at some stage because we love running things from home, and that is not something that I have experience in. The reason that I don't is that I live on the east coast of South Africa, and while my
How
home has solar power and therefore
how you
continuous
can hear
source of
Andy
power,
talking.
I also
That's so
have
funny. Was it in the
uh, Victor and Hamish are together, I think. So I'm glad that it's funny, at least. Thank God, otherwise, how are we going to get through a whole hour of me stumbling through Eth2? Hilarious. So the problem that I have on the east coast of Africa is not necessarily power, although South Africa is going through all sorts of like rolling power outages, which makes running your own hardware really difficult. The problem that I face there is bandwidth. It's really, really difficult for me to stay current, to stay with the tip of the chain, given that the internet line that I have there is supposedly 8 Mbps, but really can drop all the way down to like 1 or below. And that is too low to communicate fast enough with other peers on the network to stay current. If you read through the docs, and I will take you through many of the links that are relevant to running your own nodes, there are sort of like lower limits on bandwidth, which is certainly like higher than 1 Mbps. And so like that was my issue. And the reason that I don't run hardware from home is precisely the bandwidth problem. This is kind of unique to, I suppose, developing countries. If you're living somewhere in the West, you're probably not exposed to this kind of issue, and should think quite seriously about running your own hardware. On the Ethereum sites itself, you will see that they have a great deal. Here's the art, by the way. Just amazing, amazing stuff. I love this. Love this image. So we'll go back to Naka at the end of the um, presentation. This is the link. Let me drop it in the chats. You'll see that like one of the advantages to running your own hardware, which Paul is doing with DappNode, and which we can talk about a little bit, is that you have a sort of trustless and more sovereign approach. It's a one-time investment. You can buy pre-configured machines like DappNode. The thing is that you have to physically prepare it yourself. Using a cloud provider, which is what I do and what I will explain during the course of this call, you're prone to cost changes. You're prone to the whims of, in my case, Uncle Jeff. But whether you use DigitalOcean or AWS or Google Cloud, you're prone to their kind of pricing changes, and that can be a bit problematic, as well as their uptime, which is generally speaking better than uptime you will be able to get running it from home. But it is something that you're not in control of, so that doesn't fully align with the goals of running your own network. I mean, running your own node and keeping the network decentralized as possible. The other place that we can go for that I'll show you at the end of the call. It's called like Project Sunshine, which keeps a track of the decentralization of Ethereum over time. Before I get into the exact specifics of like what I do and how you can think about running your nodes, there is just a little bit to go through in terms of like, okay, what is what is a node? What are we actually doing here, and why is it different from what we were doing in the past? So in the past, you could run a node using kind of the most popular one is Geth, that provides for 78% of nodes run on Ethereum. It stands for Go Ethereum. It's the longest running client on Ethereum. There are a number of other options. There used to be the parity one. There's something called Aragon, and one other that I'm probably forgetting right now. Parity is written in Rust. Aragon, I don't actually know what it's written in. If somebody does, please pipe up now. And those Ethereum 1 nodes were really just responsible for, like, what a node does is it connects to a whole bunch of other peers on the network, and it shares data with them, as well as receiving information about the state of the chain, which it uses to build up a local index, right? A local database that contains all of the things that go into the state of Ethereum. You can run different kinds of nodes. The most common one is something called a full node. The full node is the one that has the entire state of the chain in its database and is keeping pace with the tip where things are, and validating transactions, but it doesn't keep track of the entire like logs and other stuff associated with the history. That is called an archive node. The difference between a full node and an archive node in Ethereum 1 is a number of terabytes, basically. Currently, to run a full node, full Ethereum 1 node, what we are now calling an execution layer node, is about 720 gigabytes. The archive node is in excess of 4 terabytes. So knowing that is kind of useful if you're going to be setting up on your own cloud provider, because you need to provision storage and you need to make sure that you have more than 720 gigabytes. I recommend 1 terabyte for now. And if you're setting up your own hardware, similarly speaking, you need to buy at least a 1 terabyte SSD. Right? This stands for a solid state drive as opposed to an HDD. And you need an SSD to sync Ethereum and chains like it's working with HDDs. It will not work. You can see that on this particular page, they also have like a bunch of prerequisites, and I think slightly further down, they have the hardware requirements in terms of SSDs, in terms of the amount of RAM that you require. They specify about 8 gigs, and a CPU with more than 2 cores. Yeah, this is a little bit out of date. I had 700 gigabytes free disk space, and that just ran out like a week ago. So I would recommend a terabyte of free disk space, and you can submit a PR to ethereum.org if you like to help them do that. You can also see what I was talking about, a 10 plus megabit per second bandwidth connection, which I don't have where I live, and it's not possible to get. It's not that I'm lazy, it's just that I live in rural South Africa, and that's just not a thing for me. So I have chosen to use AWS to run my execution layer node, which is what is responsible for kind of collecting all of the transactions, indexing them in a local database, and then using that state to validate any state transitions that happen at the tip of the chain. So when you submit a transaction on Ethereum, then that transaction changes the state somehow, and we have to validate that those state transitions are indeed allowed according to the rules of the protocol. And in order to do that, we have to have the whole state already. And that's what's going on in the execution layer. These days, since the pandas merged, we also have an extra little part to things. And it's actually been going on for some time. The beacon chain has been running for a while, right? But now it's fully in operation and is responsible for maintaining consensus across the network. This is the shift to proof of stake. Rather than burning a whole bunch of energy to prove that we have done the computation necessary to find the nonce that allows us to mint the next block, we instead put up a whole bunch of money at stake, which can be slashed if we are shown to allow malicious state transitions, right? Changes in state that are not permitted within the rules, within the consensus algorithm within the rules of the network, not the consensus algorithm. And this new consensus algorithm is called proof of stake. So these two things are kind of required to run a node at the moment in Eth2. And as you can tell from me going through this, there's a fair degree of there are many different moving parts, right? Because with our execution layer, we have the option of running Geth, Besu, Aragon, and I think one other that I'm also still forgetting. Please forgive me. And with the execution layer, there are 5 clients that you can run. I'm going to talk about Nimbus today because I worked at Status for quite a long time, and they're the ones who are responsible for the Nimbus client, and it has a particular focus on light client applications, which I happen to be interested in and am keen to support. But there's also Prism, Lighthouse, Teku, and Paul, do you know the other one? Nimbus, Prism, Lighthouse, Teku, and one other. Nethermind. No, Nethermind is ETH1. That's the one that I was forgetting on ETH1. So you can tell that there are like many different options in terms of the clients that you run for your execution layer, and 5 different options for the clients that you run for your consensus layer. And that makes things already like, oh my God, like how do I navigate doing this? Because there's so many different options, and each of them implies different trade-offs.
Is it Prater, Andy? I'm not sure.
Prado was a test network. Yeah, there've been a number of different test networks. Prado was a test network. It was not one of the clients. But yeah, that's still going. It's maybe what you're connecting to with DappNode, if you're not running it on the main network.
I'm just reading through like the options for clients here. Yeah, I'm not sure. I see Lighthouse, Nimbus, Teku.
Lighthouse,
Lighthouse,
Teku, Nimbus, Prism, and that's it. Okay, so there's one other, but there are all of these different options for what you run for your execution layer node, for what you run for your consensus sort of beacon node, and then connected to the beacon node are your validators, right? Which are just public-private keys that have 32 ETH stake associated with them. Now, before I go any further into that, because that's kind of like a big stopping point, 32 ETH, everybody's, well, I mean, at current market prices, that's, like a fair chunk of money. I think the market at the moment is about $1,600 per ETH. And so, 32 ETH is like much more than like your casual person running stuff from home could likely afford. So before I go deeper into like how we actually do this and what the options are, and I allow Paul to talk about like DappNode, which is really just like a piece of hardware that you can buy that has all of the stuff already preloaded on it, and you can kind of like spin it up and run your own node without going through some of the like detail that I will cover here. It's important to know that if you don't have 32 ETH, that doesn't mean that you can't participate in securing the network and potentially benefiting from that. The thing that I really want to point everybody towards as far as is possible is Rocket Pool, right? This is, as far as I'm concerned, and please, like, I am a limited and biased person, so take it with a pinch of salt, but this is the most interesting way in which you can participate in Eth2 without having 32 ETH. Right? So Rocket Pool have been going for an enormously long time. They began building stuff when Vitalik wrote the Morve paper like 5 or 6 years ago. They were the first people who really were thinking about, okay, like how is it possible to run MPC, right, multi-party computation in a truly decentralized and transparent way that will allow people to participate in this network without having to put huge amounts of money at stake and run their own nodes. So what Rocket Pool provides is this decentralized MPC infrastructure in tandem with open source smart contracts that you can see yourself in, which have been audited by basically everyone, including like Consensus and Trail of Bits and 2 others, Open Zeppelin and somebody else. And they, with that MPC infrastructure and the smart contracts, you can put as little as 0.01 ETH, I think, in and participate in like the staking, and that gives you a pro rata share of node running in the MPC. But like it does it in a way which is very, very different from like the other options that people use, like for instance Lido, which is the other one that has by far like the most users in it, but does not provide the same degree of like value alignment as Rocket Pool does with like the MPC setup and the open source smart contracts. You can see that like with Rocket Pool you can stake and run your own node, and that cuts the cost to 16 ETH as opposed to 32. That still is like a fair chunk of money. If you want to just stake ETH and participate, you can deposit as little as 0.01 you receive RETH back as the staking token. It accrues rewards over time, but it's truly decentralized and it's non-custodial, right? Like you don't give your money to a custodian like Lido, who then like who you have then like a promise against, right? You put your money in a smart contract, which has been audited by all of these people, and it earns interest over time. In addition to that, like the MPC setup means that any penalties incurred by the node operators, if they validate the wrong state and get slashed, you're protected from those. You can see that there are slight differences in terms of the APR that you can earn for this, which is, I think, why more people are using Lido. But honestly, it surprises me that like here you can like earn 3.61% APR with Lido. I think that's you can earn, I think 4% is kind of what's the offering is. Yeah. Okay, 5.5%. So like, I suppose like if people are just in it for the money, like that helps explain like why it has greater adoption than Rocket Pool. But like if you're genuinely interested in like learning from this and participating in a values aligned way with what is happening in ETH2 and what it really means to like participate in decentralized networks together, I don't know of a better way of doing that other than Rocket Pool. So if you just have like 0.1 ETH and you're like, I just want to like learn and see what this is about and what it means, like how I can like play my small part, like I think that Rocket Pool is without a doubt the best place to go. They also have a really great community. You can find them on Discord. You can learn a lot from their smart contracts on GitHub. And if you're an infrastructure person, you can learn a whole bunch from the way that they have set up like MPC and do their thing. So that is my like one shill for the day, is if you're not in a position to run your own node from a financial perspective, let alone a hardware perspective, then like this will just be like a fun, entertaining cooking show for you. And like Rocket Pool is what you should like play around with and see where it leads you if you just want to like put 0.1 ETH in and kind of play around, as well as join like a community of people who really like care and who are values aligned about what it actually means to create and participate in decentralized networks. So there is that. Before I go further, are there questions, comments, jokes, swear words, anything else that anybody has? Okay, cool.
Sorry, I have a question.
Yes, please.
I have heard at one time or another that there's a difference between running a validator and a full node. Is there like a difference in terms as far as you understand it?
Well, I'm not exactly sure. You see, this is one of these things that like people use the word full node to mean like different things. And prior to the merge, which happened a day ago now, you could run a validator client and simply kind of pass it a Web3 provider URL, because all the beacon node needed prior to the merge was information about the staking contract on ETH1, right? So like, for instance, I was just running like a single Nimbus machine in AWS. And when I like started it up, one of the things that it requires is a Web3 provider. And I would pass it an Infura provider because the only information that it needed was like the state of that staking contract on ETH1, so that it knew who were valid validators. But now that the merge has happened, right, Infura and these kinds of people do not provide that. You actually need to run your own execution layer node, because there's a bunch more communication happening via this engine API. And it means that you have to run your own full node, right? So I've had to figure out like how to set up and run Geth. I chose Geth because I had experience with it back from like 2015. But of course, running Geth now as opposed to 2015 is a very different story. And I understand by full node to mean like a full Ethereum 1 client. And in that case, there is this difference between like the full execution layer node and then the validator clients. They're like separate things. But post merge, you have to have both of them because like the validator, the beacon node is where you're like keeping up with the tip of the chain, and the execution layer is where all of the data is coming from, basically, because all of the data and transactions still kind of sit in ETH1. Does that make sense? Did that kind of answer the question?
Yeah, so I guess what it boils down to is like post-merge, when we talk about running a node, are we all definitely talking about the same thing?
Well, yeah, you have to run your own like full execution layer node, and that is a part of what running a node now means, because like it means like having a full execution layer node and the beacon node consensus layer, right? People, if you go into like the discords where this kind of stuff is discussed, people always abbreviate it like EL execution layer, CL consensus layer. So you need both like full EL and a CL client of some regard to run a node in Eth2. That makes sense?
Yeah, thanks.
So one more quick follow-up question. Is there still a concept of like a witness client? So just you're there, is that the archive node, I guess, functionality? Has that been included in all of this, or is that still separate?
It's actually the other way around. So the archive node is like, I'm doing everything, right? Like I want it all. I run an archive node because I, for instance, run a provider service like Infuro or Alchemy, and people are going to be querying me not just about the current states, but also about historical states and logs. So like generally speaking, the only people who run archive nodes are those kinds of like enterprise level providers. Because like running an archive node is, I think it's over 4 terabytes. I'm not sure of the exact like storage requirements, but it's steep. The witness clients is what I understand to be a light client. That's just like they're observing the tip of the chain, not participating actively in like the consensus, nor validating those transactions, but just receiving the state's root from a full node and then like participating at like the tip of the chain. And this was always like running a light client is like there's a long history of how difficult this has been with Ethereum. So like for many years I worked as like a DevRel person at Status. Status was this mobile client on Ethereum. The whole point was to have a light client running on your phone, right? And that meant that we could allow people to participate in the network and then like, you know, hopefully like expand the number of people like participating meaningfully, although we never got to the place where we could have a light client that was actually kind of itself validating transactions, which is what it means to participate meaningfully in this network at a technical level, right? So like nobody was ever really able to build a light client as Ethereum and the state grew that was like good enough to participate meaningfully and like stay current with the tip of the chain without consuming too many resources and without requiring too much storage for a mobile phone. There were many different attempts to do this, the most prominent of which is something called LES, the Light Ethereum Subsystem, and Trinity, which is a project still going on led by Piper Merriam at the foundation, which kind of tried to split state, history, and gossip into kind of 3 different networks, and then have those speak to each other in a better defined API, through a better defined API that would allow for the meaningful participation of light clients. Pipe is an incredible guy, and that team has done really, really good work, which has filtered into how we're thinking about what these witness or light clients might look like in Eth2. And it is the reason that I am running a Nimbus node as opposed to Teku, Lighthouse, Prism, or the others, because Nimbus is once again a research project funded and started by Status with the specific aim of actually having working light clients that can be run on resource restricted devices, not just mobile phones, but like most people who run Nimbus clients do so on Raspberry Pis. and like ARM chips, this kind of stuff. But Raspberry Pis are the most common, and I love that, and I think that it's very important. And I am not quite au fait enough with the exact technical details of what these light clients will look like in Eth2 to say anything more at this stage, Sparrow. But I hope that that gives you a perspective. Like, there are people who care a lot about this. Nimbus is definitely the validator clients, the consensus layer clients that is closest to being able to run meaningful light clients for Eth2. And what exactly that will look like, in order to describe it, we'd have to get one of their like core team members up to talk about it, which I can do later on in this block if you like, but I don't have the technical expertise to say.
Yeah, no, I'm really interested because I also think it's really super important, and it's that meaningful participation in the network that not everybody's going to run a node that requires terabytes of storage and consumes. I know we set up a validator node for Palm protocol, which is effectively Hyperledger Besu, which is just a copy of Ethereum, right? Just a few pull requests behind or whatever. And we set it up it's a full validator node, and it's like $500 a month to run. So even without the 32 ETH staking, just sheer processing power and resource consumption is still really expensive.
Yes. Yeah, you're doing well at $500 a month. You're doing really well there. Yeah, you're about right. That's running these machines in cloud service providers. You have to have a particular kind of machine, as is specified here. You know, like these kinds of requirements here: 8 gigs RAM, 1 terabyte free disk space, and that amount of bandwidth. Yeah, like you do well to get this running for $500 a month in something like AWS or DigitalOcean or the like. I run into similar costs myself, and it is not. Like this is one of the barriers toward like true decentralization and meaningful participation, is that like to do this kind of stuff, it does require like really like rather surprising and steep amounts of upfront capital, and that is difficult, particularly if you're only running a validator. Like if you're only running a node, like and not actually like participating in like these like validations, thereby making yourself eligible to receive rewards, then like you're just burning like $500 a month to participate in the network. And this has long been a discussion amongst people like deeper in the technical community, even before Ethereum began, right? If you go back into like the Bitcoin community, there's like this talk of altruistic verification, like who's really going to do that? If we're going to have like truly decentralized networks, we need people to run nodes, but like that has a cost associated with it, which is growing as the network grows, and who is really going to bear the burden for that? And I'm not sure that we have like a wonderful answer to it yet. This is one of the reasons why I point to Rocket Pool, because these kinds of like multi-party compute, truly decentralized, open, smart contractified setups are like a really, really interesting solution in that direction that allows many people to participate meaningfully without having to bear like the brunt of some of these like setup costs and then just running costs, because like it's not just the cost of a machine that has that many CPUs and that much RAM in clouds somewhere, but also like the bandwidth costs. I have found that the biggest cost for me running a Nimbus node in AWS has been data costs in and out.
Yes, for sure. It's the bandwidth in and out.
Yeah, exactly. Running the machine, especially for Nimbus, because it can like run on a Pi, like the machine is a tiny little EC2, and that costs like very little, but it's the bandwidth that data costs are a lot. also in the region of like, I don't know the exact numbers off the top of my head because I've been like changing things and messing around, but it's like for one machine, it's like also like, I think in the region, it moves between about $420 and $600 a month. So like, it's not a cheap exercise. All good things to be aware of. Thank you for bringing that up. It's a really, really good question, Sparrow, because I want to be as open and transparent about how much this stuff really implies as we go through it. Before I go further into that, now that we have like a overview of what a node is, why you might want to run it, because like participating meaningfully is what leads to really decentralized networks that give us our own agency and the ability that we have to shape the world. Before I go further into that, Paul, I would love to you can just tell the story of like getting your DappNode and what it's been like, because if you buy a DappNode, all of this complexity is somewhat abstracted away and you just get a little piece of hardware that allows you to plug it in and off you go. So
sure, and I can share a few screens also, and yeah, I'll tell the story of how I set it up. So I guess with a lot of us being interested in the merge, and there was a lot of chatter online. I also wanted to know more about what the infrastructure looks like. So I think the first thing that I discovered, well, I've been seeing a lot of what Superfizz has been talking about. I think that was what really led me to exploring how to set one up. So let me link that here for everyone. Maybe I can share my screen also, Andy, if that's okay. Sorry, let me fix my cameras. Yeah, so I think just going through this tweet from Superfizz, like he just describes what you need to do, all of the links down there. Frankly, though, I think it's still hard. It's not really that easy to stake. You have to go deep into the command line, and that's something that I think it might not be that hard, but I didn't really want to go through that. So one of the links here was, well, first you need to get the hardware. So this is what I got. I didn't buy a DappNode, Andy. I put it up myself. So I just bought one of these Intel NUC machines. And then when you buy them, you need to buy a hard disk as well and some memory, I think. So I had to buy that in addition. So it cost around, I guess, $800 is the total cost to be able to set up your own node. And I did send the picture. It's similar to this one, so that I just have it running up there. And I'm connected. I just got a new connection, which is pretty fast, fiber connection, but I had a connection that was 100 Mbps before. It seemed to work well, but it took me around, I guess, around a week just to sync everything up. But once everything's there, like it continuously just syncs everything. So I think the data usage becomes less once you've synced everything up. Yeah, so I put that up, and then oops, sorry for scrolling so fast. But when you look at the links from Superfizz, he'll tell you what you need to do. Oops, why is this not finishing? But a lot of the initial setup was around creating your wallet, creating the mnemonic that you will need to send to, I think, to the Beacon chain. I didn't do that yet, so I guess that's also what I wanted to learn. So what I have now, Andy, is just it's just an execution layer node, right? The one that's running the blockchain, but it's not staking as of yet. So it's there, securing the network, but I'm not getting anything yet. I just wanted to figure out what does running a node look like and how do you get it up. So again, I guess going back a little bit here to when you have your hardware, you just go download the ISO from DappNode, which is an ISO file. Can download it here directly. And if you guys know how to burn a CD, it's similar. I use this software called Rufus, and I think this is what they recommend as well, to burn it to a USB drive, an 8 gig USB drive. So you burn it there, and then you install it to the machine, And then that's honestly, that's basically it. So once that's all set up, you'll be able to connect to your DappNode. One gotcha is, I think it's better for it to be wired. Initially, I put it on a wireless network, so it didn't sync as properly. So now it has a LAN cable connected directly to my router. And then what happens is you're gonna have two networks already, so your own network, and then the DappNode will create its own Wi-Fi network, which you can connect to, and then you'll connect to, I guess, because it's in a separate network, because I'm gonna have to show it to you guys through this iPad. I don't know if you can see it, but it's like you connect to my DappNode, which is the URL, and you'll see like a dashboard of your node. So here you'll see like you see here it's green. This means it's synced to the current to the latest chain. But that will take a long time. So that's what I had to wait for a whole week to be able to sync. And yeah, so from here, you'll be able to see how your node is connected. And DappNode, I guess, in addition, if it's a Debian install, I think. It's a Debian ISO. So you can actually use it for other things. There's a Dapp store on DappNode. So like you can install other, I guess, nodes there. Like there's Mysterium nodes as well, XDAI, and some other things, Avalanche as well. So you can use it for Avalanche. And I think you can also use it as an IPFS node. So yeah, so if you just want to get an execution layer up and running, it's pretty easy. My challenge was, yeah, you since you're running the node by yourself, you do need 32 ETH to stake. And I wasn't really that comfortable yet to put 32 ETH in there. And yeah, so I'm still trying to figure out what the next step is, but I do have the execution layer running. I think you just need to, at the first part of the guide here from Superfizz, a lot of it talks about generating your mnemonic. There's a deposit tool, a staking deposit CLI. So that will create the mnemonic that you'll need to send someplace else. So I wasn't really comfortable yet with that. So I'm still gonna try go practice it in the testnet first before I do anything on the mainnet. And if you go through the whole of this, it will tell you how to do all of this in command line without using the DappNode. But I think the DappNode is the easiest one to start with, just to practice how to do it. And yeah, that's my experience, Andy. So not a lot. I still am not earning anything from this. I just wanted to learn how to use how to build your own node.
Wonderful. Thank you so much. Yeah, it's
Yeah.
a little bit disingenuous to say that it's easy. I think that
It's
there
not
are
too
lots
easy.
of different moving parts, and that's the perspective that, yeah, it's not very humble. It's not. There are lots of different moving parts. That staking Clyto is, yeah, like a good thing, I think, to mess around first on like a test network and just make sure that you know what you're doing. It is like fairly straightforward. It'll lead you through. There's like 3 steps to generating these keys. Basically, like what happens there, right, is that there is a contract on Ethereum 1, right, in the execution layer that we now use, where you send funds to the 32 ETH that allows you to participate as a validator, and proof of that, right, it needs to somehow be passed into your validating clients, so that every time you validate states, the network and your peers can ensure that this is coming from a peer that does indeed have a key pair on it or associated with it that has made a deposit into that contract, and therefore that makes them eligible to participate in validating state transitions. Right, so that's like the high level concept, right? Like put money in a contract, make sure that the client you're using to validate state transitions has a strong link to that particular deposit in the contract, and therefore is allowed to participate in validating state transitions. And if it's if it participates in a malicious manner, then you will get slashed. It's important, and I think that he is correct to say that like this language of slashed can be like really anxiety inducing. And it is worth saying at this point that like there has been an enormous amount of research and work put into what precisely it means to like have a dysfunctional validator, right? Because there are many, many reasons that a validator might not be available to participate in like validating state transitions. So you could be offline for a moment. You could be just behind the tip of the chain. There could be, you know, like gossip issues between you and your peers, latency and bandwidth problems, or you could like legitimately be trying to validate a malicious state transition that gives you more coins or this kind of stuff, right? And how do we tell the difference between these things? Well, there's been a lot of research and work done into that, which is encapsulated in the sort of penalties and rewards section of the design brief in module 6. If you go and have a look at it on the kernel websites, there is a summary given of that kind of stuff. And the idea here is that you give all participating validators some base reward B, and you multiply it by the portion of validators that agree with your particular like states transition. B times P is the reward that you get, and if you're not participating, then you slowly get like the negative of that, basically. So if you're down, and I have been running validators on like the main beacon nodes since Genesis, and there have been many times where I messed something up, or like the software fell over, or there was a bug, or this kind of thing, and like it's not a problem. You just like lose like 0.001 ETH, 0.00301 ETH for like each attestation that you miss, basically. Just as I at the moment earn 0.0001 ETH for each attestation that I make that is in agreement with the rest of the network. So like being down or not, like having an issue in your validator does not mean that like you will lose all of your ETH in one fell swoop, right? There are very, very particular conditions under which the slashing thing happens, as opposed to what I've been talking about, which are technically called inactivity penalties. So you get these small little inactivity penalties if like your node is not functioning as it should. If you try to validate a state transition that is not legal, then you will get slashed. And that, again, like there are different levels of this, and it doesn't mean that you immediately lose all 32 of your ETH. There's like different ways in which the slashing occurs, although it is more it's a higher penalty than the inactivity leaks. And the only way that really happens for those of us who are actually just trying to like run validators and do the thing and are not like mainframe hackers trying to take over the network is if you like, the only way that it's happened that I've ever seen, and I think will ever be the case, is that like people try and like move their validator from one machine to another, and then like this initial machine is still running, and then they like spin up the other validator with the same key pair, and then they have like the same key pair trying to like validate the states at different times, and then like the network reads that as like malicious behavior and can slash folks. So that has happened. So that's the only thing to really be aware of as you think about this stuff, Paul, in particular. Like if you do move machines, if like your DappNode, something goes wrong with it or whatever, like just make sure that it is really stopped before you like put your keys on another machine and spin it up and start participating again. Because if you have two machines with the same key pair, that's a potential slashing.
Can you tell it's stopped, Andy? Like, is there like an ether scan?
There is a website which is called beaconchain.in, right? And here you can, on this website, like when you use the deposit client tool, it will come up with like a 0x long address, longer than you'll see on ETH1, and like that's your like validator public key, and you can like see the status of your validator there. And generally speaking, this website will, like in my experience, when I stop my validator, it takes about 6 minutes. It takes 2 missed attestations for it to reflect inactive. So like if I show you, here you go, you can see like this is what a validator page looks like. That's like the public key that the deposit client tool will generate. And you can see that this one is currently active. If I stop the machine that it's running on, it takes about 6 minutes for that like active green button to go red. I'll just start sharing my screen again. And yeah, I'll share my screen after this. Yeah, it takes about 6 minutes for that green button to go red. And then I know for sure that it has definitely stopped and like the network is seeing it as stopped. And then I can like spin it up again in a different place. There are some there's like a great deal of other things if you are changing machines, which I'm happy to help you do because I've done it and it is like a little bit finicky. So I'm very happy and available to help with that kind of stuff. But that's like the basic high level thing there, and you can see what a validator looks like. Right, so I am gonna come back to just like the rest of my particular setup because it might be worth sharing that for folks who are into this. The next part that I want to share is so like given Sparrow's question, you can tell that I am really into light clients and what that might mean for the ability for people to meaningfully participate from places like Africa on mobile phones or other resource restricted devices that they already have without requiring them to get access to like high-end hardware or this kind of stuff. Here is the link that I used to set up my Geth machine in AWS, given what I talked about in terms of like the bandwidth problems and the fact that I can't run this from home like Paul is doing. This is a really, really wonderful guide which will take you through like a few things in AWS specifically, right? The thing to be aware of as you go through this is like, I've gone through this guide, it works well. I'm happy to lead you through it if you are thinking about running your own Geth node, your own execution layer node. And what this guide is doing at a high level is it's saying, well, we need a really, really beefy machine that has like a lot of CPUs and a lot of RAM in order to sync up with the chain as quickly as we can. We want to try and get it done in like 24 hours, which is roughly how long it took me to do it following this guide. So we need this really beefy machine to like get up to speed with the chain, but we don't want to have this really beefy machine as our like long-term machine because that'll cost us much more money. So what we're going to do is we're going to like start up this really, really beefy machine. They say an i3x large. I actually went with an XX large. That's the one gotcha in this particular piece. And we're going to, Amazon has this really great service, although it's like the same in Google or DigitalOcean, where you can like attach some, in Amazon it's called EBS, elastic storage, right? You can attach some storage volume to your machine. And like basically what this guide tells you is like spin up this machine, attach a storage volume to it that you write the chain state to, the database which indexes all of the stuff on Ethereum. Take that elastic storage volume, unmount it from this really big machine. Once it's been synced, mount it onto a much smaller machine, which will be cheaper to run in the long term, but still be able to keep up with this, with the tip of the chain, and off you go. Right. So this is also like for me why like that tweet is kind of like a little bit misleading, because sure, if you buy like the hardware that he's talking about, that's wonderful. And if you have $1,000 to spend on setup, that's great for you. This particular method that I'm using here is also not cheap, right? So my costs in Amazon also for running this amount to around $500 a month. And so like that is going to be like a little bit more expensive over time. I think I've got it down a little bit. I think it's a bit below that because I have changed the machine and done the thing. But there is like a great deal of technical specificity around how you mount a volume, how you unmount a volume, what you do with this stuff. And I'm willing to lead you through it like if this is something that you do. But just at a high level concept, I like Geth because it was the one that I was most familiar with from the early days of Ethereum. It's the longest running client. I kind of recommend, I'm really happy to hear that Sparrow's running Besu and like off the Hyperledger stuff, because like Geth accounts for 78% of clients on the execution layer, and that kind of sort of market dominance is not a good thing for decentralization. Back in the day, the two most common clients were Parity and Geth, and it was really, really important that we had that, because there was this massive DDoS attack on Ethereum back when we did DevCon 2 in Shanghai, and the DDoS attack took down Geth, every Geth client. And so if there wasn't like enough Parity clients being run at that time, the network may have halted. It did not, but the only reason that it didn't was because there was a whole bunch of client diversity. So like, definitely think about running other clients. Besu is great. Nethermind is an option. And there was one other now, which I'm kind of forgetting in the stream of things, but like it's worth experimenting with those. I happen, just because like I was like, look, I am familiar with Geth. I've used it before. I used to run it on my laptop. So it was really, really funny for me to kind of come back and be like, well, you know, I used to run this thing on just like a normal laptop. It was no problem. And now I have to go through this whole sysadmin thing of like spinning up different machines in AWS and working with EBS and mounting and unmounting volumes and doing the thing just to like run a Geth node in a reasonably like financially efficient way in AWS. This is the link to use if you want to do that.
One other thing to maybe explore. I mean, Consensus provided. So I come from a DevOps background, right? And Consensus provided some really nice Terraform scripts that did all of this stuff for you, right? I don't understand. Maybe they just haven't done it for Eth2 yet, but that would be something that would save all of this manual configuration, right? You just
yeah, absolutely. And like if we can find those Terraform scripts, I mean, let's link them in the channel and like explore those, because I'd be like really happy for other people not to have to go through this. I learned a huge amount, right? And that's why I'm presenting it here, because like kernel is all about learning together. And like now I'm like kind of a sysadmin. Not really, don't trust me, please. But like it was kind of fun for me to do these things because I had like a particular frame of mind associated with it. But those Terraform scripts are really great. AWS also provides a managed node solution, right? So you can like just go into your EC2 dashboard and like run a managed node. But like, again, I was like, no, I don't want to do that. I don't want to trust Amazon to manage my node. I want to do it myself. And of course, then like at one stage when I unmounted the volume in the incorrect manner and messed things up, I was like, oh, why didn't I just let Amazon manage my node for me? But like, it's, like there's a great learning opportunity.
Completely get that, right? When I first, running a node is, in my opinion, the best way to understand what blockchain is actually doing. So, when I first came across blockchain, it wasn't Ethereum, it was a distributed proof of stake chain. And I set up a validator node with them. And that was how I learned how distributed proof of stake worked and how blockchains worked. And it is the best learning experience for what underpins all of these other things that we do.
Yeah, exactly. So, I mean, decentralize the network, learn a bunch, have fun. All of these things are a big part of it. Of course, there's like the financial cost, which makes it less fun and less easy to learn. So we're also thinking about that at kernel. I must admit that like, are there ways in which we can use groups like this in order to make it possible for more people to experience the learning that is available through this without having the financial concern and difficulty that might arise from like wanting to do this kind of stuff? Are there ways in which we can like route application fees, for instance, toward like shared validators? These kinds of questions where, like what are the unique ways in which we can use Web3 and the environments and the communities that form around it in order to like continually enhance learning? And it's not just like this like same old fee structure or other things that you see in Web 2, but like something genuinely interesting, communal, and innovative in terms of the way that we run this. So like I'm exploring that, but like I don't have anything more to say about that right now. And I know that we've reached the end of our time. So if you need to drop, like please do. The last thing, and I won't be offended. So if you need to go, please, like it's no problem. I really want to respect your time. And thank you so much for spending an hour listening to Paul and I cook up a node together. We haven't touched the sort of actual validator part of things, either in terms of the validator CLI tool and making like creating your stake, or in terms of like the validator layer. I use, as I say, Nimbus, and this is like a really wonderful team. It's a really wonderful tool. It is specifically for light clients. Nim is a language that this team has sponsored. So the people who write the Nim language and build the compilers are a part of the Nimbus team, and that's really interesting in and of itself. They have a wonderful documentation, which I can highly recommend. I've spent a lot of time in here figuring out how to do the thing. If you want to learn more about like making a deposits, here's a bunch more documentation about like what that incorporates, how you get your keys, and then how you import those keys into your particular validator. And as I say, like what my setup looks like is Geth for the execution layer, which I'm running on a machine in AWS, and then Nimbus for the consensus layer with a key that I generated through the deposit CLI in that node, which helps me validate state transitions in Eth2 and earn rewards for that. The rewards are still kind of a bit low at the moment, but it's interesting because we now stand to earn transaction fees as well, which was not the case just running the beacon node, which is generally speaking, it returns currently it's like 6 to 8% APR, which is still kind of good, but like not enough or just enough to break even with the costs of running a validator if you're using AWS. I've been kind of breaking even depending on the price of ETH and depending on the cost of data that particular month. I've been kind of breaking even running a beacon node validator. And now that the merge has happened and validators stand to receive transaction fees associated with the blocks that they validate, that return might go up a little bit more. We'll see. Some people are quite excited about that, but the economic models are still kind of variable given that there are so many variables at play, like the price of ETH, the price of data in different places, the price of running these machines in different ways. So it's quite difficult to make exact predictions. But it seems like it will be a slightly profitable thing for me to do. Not enormously so, but enough to kind of justify this as a learning experience that bears some reward for me. If, as I say, you like haven't been around Ethereum for a long time and this kind of stuff is really outside of your current capabilities, like Rocket Pool is a really, really great place to go and stake a little bit of ETH, participate in the community, learn a bit more about what all of this stuff is about, and sort of get going further into the Eth2 journey. Yeah, I think that I'll stop there for now. And if there are any further questions, we can deal with them asynchronously and jam the merge, or shoot now. And I'm happy to continue.
I just wanted to say thanks to Holly for mentioning all nodes. That looks really interesting.
Amazing. Yeah, I don't even know that.
Yeah.
So Holly.
Yeah, so actually what you want to do is go to the staking of the service page. Here, I'll share it with you right here. And there actually might be better choices here because they have ones that are audited, like blocks staking, BLOX staking. It says it's audited and open source, whereas all nodes is kind of, but it's battle tested. So it seems to be working pretty well. And I've been using it for a year plus, so a year and a half or so. The problem is you get lazy. You don't end up wanting to run your own node when you have that going. And I didn't get the special ASCII art either that Andy got and when we switched. So, but other than that, it's been working really great. So it's a possibility. You know, the other thing, like if you do have a problem with, you know, your hardware or something, you can always switch it out, like Andy mentioned. You know, move it to a staking as a service node until you get your hardware dealt with or something like that. You know, so it's kind of it's a good fallback place too if you wanted to move your validator, your keys over there temporarily to, you know, avoid getting not slashed, but just getting losing some, you know, some of these attestation and proposals. So I don't know, that's helpful.
Thank you, Holly. Yeah, absolutely, very, very helpful. And having backups and like sense that there are like many avenues and ways that people can help and things that you can do even if things go awry is really, really good. And I must admit, the pandas were worth it, right? All of, like 5 months of tearing my hair out. It's totally worth it just for the pandas. Yeah, it's really, really good to have those alternatives. Okay. Anything else? Otherwise, I will stop the recording. Wonderful. Thank you so much.